Let's factor this one. The first thing you do in all factoring problems is look for the greatest common factor. So we're looking to see if there's a number and x's that go into both these. So if we look at the biggest number that goes into both 12 and 8, well, 2 goes into both of them, but so does 4. Does anything bigger than 4? No. So my GCF, called the greatest common factor, is going to be 4. Now, since that negative's right there, I'd rather that be a positive, so I'm actually going to pull out a negative 4. Now you could have pulled out a positive 4, but I'm doing negative 4 just to show you something. Anywho, and then out of these two powers, you have x to the third and x squared. What's the most amount of x's you could take out? Well, since this has x squared, you could actually take out x squared, because if you pull out an x squared, both of them have an x squared in them, so you could yank out the x squared. Now, once you do that, we have to find the two pieces left over. So, negative 4x squared times what will give us this? Well, negative 4 times 3 gives us negative 12. And what times x squared gives us x to the third? I think that's x. So this times this gives us negative 12, and this times this gives us x to the third. Okay, this times what gives us this? Well, what times negative 4 would give us positive 8? I think that's negative 2, so this is a minus 2. And x squared times what gives us x squared? Well, it's just 2. So actually, that cannot be factored anymore, so this right here is actually our answer. Pull out the GCF, factor what's left over if you can. This particular problem, if I want to factor this, what we do is make this little x thing. It's also, people call it the diamond. You put this number on top, you put this number on the bottom, and once you do that, you're now trying to find out the top. You're trying to find out two numbers that multiply to get the top and add to get the bottom. So two numbers that multiply to get this and add to get this. And you kind of go through all your numbers, like you try 24 and 1, no. 12 and 2, no. 6 and 4 does work, because 6 times 4 gives us 24, and one of them has to be negative because that's negative, and what? That'd be 6 minus 4, right? 6 plus negative 4 is 2, and 6 times negative 4 is negative 24. And what do these two side numbers mean? Well, that's how you get your factored form. You take those numbers, so this is an x, go x plus this, and the other one's going to be x minus that. That is factored form for this particular quadratic. Now, number 3. Looks a lot like this one, but the first, look at here. See the GCF here? Is there a greatest common factor? Yeah, there actually is. My GCF for this particular problem looks like it is 2. I could actually pull the 2 out. When I pull the 2 out, what you see is when I 2 times what gives you this, looks like x squared. 2 times what gives you this, looks like 5x. That's a plus. 2 times what gives you 12, it looks like 6. That'd be positive. Okay, so I pull the 2 out. Now this I could actually factor, just like the previous problem. So just like the previous problem, I put the 6 on top, the 5 on bottom. Now I'm trying to factor it. So two numbers that multiply to get 6 and add to get 5. I think that's 3 and 2. Yep, 3 times 2 is 6. 3 plus 2 is 5. So what I'm left with is that's x plus 3, and that's x plus 2. So this factors as this, but don't forget there's a 2 out front. A lot of people forget that 2 that sits out front. Alright, number 4. If I want to factor this, it looks like I might be able to pull the GCF out because this number in front, but I can't. Now if you look at this one, there was no number in front, but when there is a number in front, it actually makes things a little bit more difficult, because what's going to happen when there's a number in front is you do the x, but you're going to take this number and this number, multiply them, and we get negative 24. So this times this. And then you take the middle, put it at the bottom. Next, we're trying to think of two numbers, just like this and this one, that multiply to get this and add to get this. And looks like it would be 8 and 3. And since that's a negative 5, looks like it gives me negative 8. So what I have is x minus 8, x plus 3. And what I'm going to do now is I'm going to, let's see, x minus 8, x plus 3. I need to now get rid of the 6 that I multiplied in. So I divide both sides by 6. Alright. Got both sides divided by 6. So now I reduce my fractions. So 8 over 6 reduces to x minus 4 thirds. And 3 over 6 reduces to 1/2. Running out of space here. But your answer looks like it's going to be, this fraction does not reduce anymore, so you take it, bring it up. And this fraction doesn't reduce, so you take this and bring it up. So my answer ends up for this one being 3x minus 4 times, bring the 2 up, 2x plus 1. Kind of ran out of space. There's the answer, because you take the bottoms, bring them up, and that's a factored form. It's kind of a little bit more difficult when you can't pull the GCF out and there's a number in front.